Hello, good to see you again. Welcome to Block 5, Fraction, Decimal, and Percentage Equivalence, Lesson 3. I'll share my screen. In your previous lesson, you learned how to represent tens and hundreds on diagrams. In today's lesson, you're going to learn the interchange between fractional and decimal number lines. So you'll be able to find the equivalence of fractions and decimals and the correct positions to put them on number lines. It's a very important skill, especially as you move on and progress in your study of maths, building really good foundation, which will also help you in graph plotting skills and graph interpretation skills. But before we start, I would like to appeal to you, ask for a favor. Thousands of people are enjoying and learning from these videos, but the subscriber numbers do not show that. But I can see the statistics. So please click the like button, click the subscribe button, and click the notification bell so that when new videos are released, you can be notified of these videos. And also share the good things. If you're enjoying and learning from the videos, I'm sure others will benefit as well. By doing this, you support our mission to educate at no cost the global population of children. Thank you. Before we start, I would like you to do this ritual practice to help you recall the things you learned in previous lessons. Pause the video and answer the questions in 5 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. For the first one, you were asked what fraction is equivalent to 0.5. The fraction that is equivalent to 0.5 is half. Next, you were asked what decimal is equivalent to 1/10. The decimal that is equivalent to 1/10 is 0.1. Next, you were asked how many fifths are equivalent to 1 whole. There are 5 fifths in a whole, and that can be written as 5 divided by 5, 5 over 5. Next, you were asked, is 13 divided by 10, 13 over 10, greater or less than 1 whole? Well, 13 over 10 is the same thing as 10 tenths plus 3 tenths. Now, 10 tenths is 1 whole plus we now have 3 tenths. So this here is 1/3. So you can see it's already greater than 1. So 13 tenths is greater than 1 whole. Okay, let's move on. Let's do some new learning. Your first example, if you're asked to place decimals and fractions on this number line, what would you do? Well, remember that we have 10 intervals between 0 and 1. So using our knowledge of how to place labels on number lines, we will find the difference between the start of the number line and the end of the number line. So in this case, it is 1. And then we would divide that number by the number of intervals that we have. So here we have 10 intervals. So each interval is 1/10. Now that we have that information, we can complete our number line like this. So each interval is 1/10. So the interval will be increasing each time by 1/10. Next, we can put the decimal equivalence on top of the number line. So the equivalent values of these fractions are these decimals on top of the number line. What about this one? Example 2. If you were asked to complete the missing fraction and decimal levels, how would you do this? Well, it will be helpful to write the equivalent values both in decimal and in fraction form of these numbers we see here. So the equivalent value of 0.75 is 75 hundredths. But that does not give us the information we need to be able to complete the labels for the intervals between these numbers. Did you remember when we shaded 100 squares? Well, 8/10 will be equivalent to shading 8 columns of blocks or 8 rows of blocks, each of the rows having 10 little blocks. So 8/10 is the same thing as 80 hundredths. And it's also the same thing as 0.8. Now that we have that information, we can complete the labels for the intervals on the number line. So we know 80 hundredths and 75 hundredths, the difference between them is 5 hundredths. And we know that there are 5 intervals between these numbers. So if we divide 5 hundredths by 5, we'll have 1 hundredths each. So each of these interval is 1 100ths. So we can now complete the labels for the number line like this. So what we've learned so far is that you can complete a number line using decimal and fractional equivalents by using the same knowledge that you used when you completed labels for integers on the number line. It is important that you remember and recall and use your knowledge of knowing how to shade your 100 squares. It's a fundamental knowledge of knowing how the equivalence between decimal and fractions work for hundredths and tenths. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and answered question 1, here are the answers. Let's discuss them. For question 1, you were asked to complete the number lines. Now you can see that the difference between this and that, so 0.2 and 0.6, is 0.4. Now we have 1, 2, 3, 4. Now we have 4 intervals. So to find out the value of each interval, we're going to divide 0.4 by 4. That gives us 0.1. So it means each interval is equal to or worth 0.1. So we can increase our intervals like that. Next, we'll use the same approach here. The difference between these intervals, 2 tenths and 6 tenths, is 4 tenths. Now we have 4 intervals. If we divide 4 tenths by 4, we're going to get 1/10. So each interval can be completed like this. You can discuss with your partner whether you believe that these decimal whether the number lines are identical. It's a good discussion point with your partner or with your parents if you're watching with them or with a friend. Here are questions 2 and 3. Pause the video and answer questions 2 and 3 in 3 minutes. You can take longer. You can work at your own pace. You don't have to stick to the timing. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. For question 2, you were asked to complete the number lines. We can see here that the difference between 0.6 and 0.7 is 0.1. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 intervals. Now, the value of each interval will be 0.1 divided by 10, which will be 0.01 or 1/100th. So, to complete the number line, we can begin to add 0.01 each time to the numbers. And that's why we get these values. Next, we have 6/10 and 7/10. The value between 6/10 and 7/10, the difference is 1/10. Now we have 10 intervals. So we can use that knowledge that if we divide 1/10 by 10, we'll have 1/100th. So each of the interval is equal to 1/100th. And we can complete the number line using that information. And you can see the equivalence between these decimals and these fractions. So you have 61/100ths all through to 69/100ths before the last number on the number line, which is 7/100ths. 7/10. And recall that 7/10 is the same thing as 70/100ths. Next, you were asked to complete the number line by filling in the empty boxes. We can use the information that the difference between 0.6 and 7/10 is 0.6 is 6/10. So the difference between these two is 1/10. So this is simply using equivalence. So that should be 8/10, which is 0.8, 9/10, which is 0.9. That's a whole, and that's 1/110th or 11/10. Okay, celebrate your success, mark your work. Let's do some new learning after you've done that. If you were given this number line and you were asked, what number is the arrow pointing to? Give your answer as a fraction and as a decimal. Well, Rosie thinks that the arrow is pointing to 5/10. And Annie thinks that the arrow is pointing to 5/100ths. Who do you agree with? Pause the video and have a think. Well, we do not really know the value that this arrow is pointing to because we have no other value on the number line to tell us how we wish to divide or value each interval in this number line. So either of them could be correct. Could be 5/10, could be 5/100ths, or it could be a different number because we do not know the other value in the other parts of the number line. What about this one? If you're asked to draw an arrow to show the approximate position of 15/100ths on the number line, How would you do this? Oh, well, we know that the difference between 0 and 1 is 1, and we have 10 intervals between them. So 1 divided by 10 is equal to 0.1 or 1/10. So we can complete our number line like this. And we can put the equivalence fractions underneath like this. But that doesn't give us the information yet of where we need to put 1500s. If you remember when we shaded 100 squares, if you wanted to represent 1/10 on 100 square, I'm sure you recall that you would shade a whole row or a whole column of 10 little squares. So you have 10 hundredths being equal to 1/10, because you have 1/10 being a whole row or column of 10 little blocks, which is 1/10 of those 10 blocks that make those 10 rows that make the 100th square. And 2/10 is 20 hundredths. So now that we have this information, we can say, well, 15 hundredths has to be halfway between 10 hundredths and 20 hundredths, and should be there. So what you've learned so far is you can use the equivalence between decimal and fractions to know where to put the location or to locate numbers on a number line. It's also important for you to note that your skill of knowing how to shade the 100 squares is very important here. So if you haven't watched that video or gone through that lesson, it is important you go and study that. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and worked through the questions, here are the answers. Let's discuss them. For question 4, you were asked, what number are the arrows pointing to? Give each answer as a fraction and as a decimal. Now you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 intervals. And the difference between the start and the end of the number line is 1. So 1 divided by 10 is 0.1 or 1/10. Now that means that as a fraction, this has to be 45 hundredths. Why? We have here will be 1/10, which is 10 hundredths, 2/10, 20 hundredths, 3/10, 30 hundredths, 4/10, 40 hundredths, 5/10, 50 hundredths. So that should be 45 hundredths, which is halfway, and it's the same thing as 0.45. Here we have 5/10 and 6/10. The difference between them is 1/10. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 intervals. So 1/10 divided by 10 will be 1/100th. So each of these is worth 1/100th. Now, if that is the case, this has to be 57 hundredths. Question 5, pause the video and answer the questions in 2 minutes. Assuming you've paused the video and worked through the questions, here are the answers. For question 5, you were asked to explain the mistake that he has made. Well, the mistake is that he has assumed the number line is going up in 0.4. Okay. Yeah. Yeah. 0.1s. Sorry, 0.1s. Now, to avoid that, it's important you know how to do your number line division, how to do your find the value that each interval gives you. Here is question 5, B and C. Here are the answers. You were asked to explain the mistake. She has mixed up the tenths and the hundredths. Okay. Next, what number is A pointing to? Of course, going to the number line, you can find out what number A is pointing to. Yeah, by working out the intervals. So we have between 0 and 1, we have 1 as the value, and we have 1, 2, 3, 4, 5. So 1 divided by 5 will be 0.2. So each interval should be 0.2. So that should be 0.6, which is 6/10. Pause the video and answer questions 6 and 7. Assuming you've paused the video and answered questions 6 and 7, here are the answers. Let's discuss them. Here you were asked to show the approximate position of the numbers on the number line. Well, to be able to do that, you should be able to do your number line division, getting 10 intervals between 0 and 1. So these are the approximate positions. For question 7, you were asked, Dexter says that 3/6 is equal to 3/10. Is that correct? Well, we can find that by marking these on the number line to show that he is incorrect. So if you do 10 divisions between 0 and 1, you should be able to show like this that he is incorrect. 3/6 is equal to a half, which is 50%, or 0.5, which is 50 hundredths, or 0.5. Pause the video and answer questions 8 and 9 in 3 minutes. Here you were asked to complete the number line using the numbers in the box. Now, between 0 and 1.4, we can see that the value is 1.4. So we need to find out the value of each interval. So we have 1, 2, 3, 4, 5, 6, 7. So we have to do 1.4 divided by 7 to find the value of 1.4 divided by 7 to find the value of each of the interval. 1.4 divided by 2 will be 0.2. So each of these is equivalent to 0.2. Then next you were asked to explain why 11/10 is greater number than 73 hundredths. Well, let's see the answers so that we can discuss them. So each value is 0.2. So when we complete our number line, we should be able to place these in their correct positions. Okay. Well, 11/10 is 1/110. So that has to be greater than 75th hundred, because if we want to write 11/10, it's the same thing as 11 hundredths. It's the same thing as 110 hundredths. So 1/110th, which is greater than 73 hundredths. Okay. So that brings us to the end of our lesson. So what we've learned so far, we have learned that using your knowledge of equivalence between tenths and their between tenths as decimal and their fraction, you should be able to complete the number line using that equivalence. Your knowledge of knowing how to shade 100 squares, shading tenths and hundredths on the 100 squares is very important in completing number lines and doing the interchange and the equivalence between the fractions and the decimals of tenths and hundredths and other fractions and decimals. Until next time, take care. Bye-bye.